Yeah, I'm good. So tell us about yourself, the subjects you
Uh,
have studied, and your expectation with this interview.
um, my name is Umair, and currently I'm studying my Bachelor's of Engineering degree with majors in Chemical Engineering at NEDUET, Karachi. If we talk about courses, I have learned separation processes, chemical process control, uh, petrochemical, petroleum refinery and petrochemicals. I've learned some other courses as well. Apart from academics, I take part in extracurricular activities and have been elected as General Secretary for AIChE and NEDUET Student Chapter for the tenure of 2021 and 2022. With this interview, I want to take most out of this opportunity to have the experience of how interviews held in different companies, and I uh, want to experience and want to mark my mistakes and want to make them better and improve myself for next coming opportunities or next coming interviews in my life in my career.
Great, Umair. Uh, have you studied any subject related to process safety?
Uh, n- Not we are learning it right now. Uh, Industrial management and safety
So
in
do you
this
know
semester.
about process hazard analysis, PHA?
Uh, no, we haven't heard about it, but we have heard about HAZOP, uh, and we have done it for our final year project.
Yes, PHA is, as you can say, it's an umbrella for the HAZOP.
Okay.
So when we talk about PHA, then it covers many procedures related to hazard analysis, like what if and failure mode effect analysis, which also includes HAZOP and fault tree analysis.
Okay.
So these are all covered under the shadow of PHA. So what do you know about HAZOP?
Sir, HAZOP is kind of a manual to describe the unfortunate situation, like a runaway reaction incident, that what you have to do or what consequences can be of a particular condition. Like if there's a sudden rise in temperature, what could be the consequences of that, and how you can control that situation by performing some action. So it's kind of a manual for every equipment in the industry, or in our case for our final year project. So if something unfortunate happens, then we can use that manual, or use those instructions to control the situation.
What are the basic steps to start the HAZOP?
I
Like
mean,
the first step, I will tell you, like for example, to starting the job, I will first cover the process safety information, which includes PNIDs, PFDs, design data sheets, and all the details which I need to perform the HAZOP, which also includes the incident investigations reports from the past, like for any incident which happened in the past, which against that the action and recommendations were generated. So that was also covered in that way. So the first step is to mark the PNIDs, or what I just said.
mark mark the PNIDs, learn, study about different incidents that have happened in past, and take things out of it, that what things were
Cover the
going
process
wrong.
safety information,
Gee.
and then afterwards, what's the second step for HAZOP?
The second step is to mark the points that gone wrong, that gone wrong at that time, and how you can control them, and do further research on things, that how you can take precautions against them. Then you can mark those parameters. For example, if the temperature is rising, for instance, at very high rate, so how will you be able to
Do you know
control the
the guide
situation?
words for HAZOP? Guide
Yes,
words.
guide also has also a none, less, more than, and it was other than. So these were some guide words that I remember.
So it means you first take the one guide word which is more,
Okay.
and then in the second column,
In the second column, you describe the situation, like if the temperature is going high, and then in the third column you mark the consequences, what could be the consequences of the situation, and in the next column you will mark how this will affect your process, and in the next column you will mark the action that is required to control the situation or to overcome the situation.
and the last
Last one is the action required, as far as I
recommendations.
know.
Okay.
Recommendations, we haven't
And
studied with.
responsibilities. Like for example, if you generate any action item related to install an independent level switch, then you have to mark the instrumentation department to install that, or the process department.
Okay.
Okay, so do you have any interest in using the simulation softwares? How many softwares you know?
I've interest in using Aspen HISIS. I've used them with our course and with extra. I take extra interest, and I borrowed a course from my friend and view those videos, 30 to 31 videos there were, and I learned it from there and from YouTube. Apart from IISs, we have used MATLAB and also Aspen Plus, but Aspen Plus is not. I have not used Aspen Plus up to that extent, but I have know how things work out there.
Okay, suppose you have a component water and you select the thermodynamic package Wilson, and you are heading towards to perform hydraulics of 100-meter line. Okay, so which unit operation you will take from the pallet for performing the hydraulics?
Performing the hydraulics pump.
So do you have a data sheet available? I did not mention it earlier.
Pump for data sheet,
I've
but
given you the length 100-meter without any elevation, and you will take the inlet pressure, which
Okay.
is 10 bar.
Okay.
So how will you perform the hydraulics? And the component water and thermodynamic package is Wilson.
You can simply, if you drag the pump to the window, simulation window, and open it, so in properties you can insert the length of the length to the point you want to exert the
Which
hydraulic
unit
pressure.
operation you used? You are using which unit operation you are using?
Pump. Yes.
What about the pipe segment?
He was asking you to do the line hydraulics, not the pump.
Okay. Now I remember something. Pipe segment is also there in ISIS.
Yeah, and then what will you do in the pipe segment?
I haven't used pipe segment yet. Sorry.
Okay, so actually it's a basic hydraulics available in the Aspen AIChE. So that's why I was asking you. So over to Bernard. Bernard must have some difficult questions for you.
Thank you. Khalid.
Excuse me.
Khalid, I know it's good evening. Khalid.
I'm not understanding what he's saying.
Can you hear me?
He's calling your name, Khalid.
Yeah.
Okay, my name is not Khalid. My name is Umair. Sorry.
Okay. Good evening.
Okay. Good evening. Thank you.
And a happy Ramadan.
I'm not understand. I could not understand you.
He's giving
Can
you the
you
Ramzan greeting, brother.
can you hear me?
I can hear you, but your
Yes,
accent is
we are
difficult to
hearing you.
understand me.
Okay, I'm going to speak slowly. Don't mind.
Okay, no
Okay,
problem.
I'm really very grateful to talk to you. And from the perspective of a chemical engineer, I'm a practicing chemical engineer and the CEO of Apple Vision Limited.
Okay.
Just like Hassan has introduced me, I'm Bernard. I have a few questions for you. Are you ready?
I'm listening.
That's wonderful. I would like you to tell us what attracted you to chemical engineering?
It's been a difficult it's been a difficult point to choose chemical engineering. I've talked to uh, my family member, my cousin. He talked me throughout the process that chemical engineering, what chemical engineering was all about. I find it interesting, and that's why I selected the field.
Oh, that's great. That's wonderful. Now, from your introduction, you talked about some of the course units you've done, among which include industrial management, process control.
Process control, yes.
Yes. Thermodynamics, chemical engineering thermodynamics.
GG.
Yes. Now, looking at these course units, you realize that chemical engineers are problem solvers. Is that true?
Yes, very much true.
That's wonderful. Now, chemical engineers in that regard are in position to identify problems facing the community and then thereafter design solutions to such problems.
Yes.
Could you please tell us some of the 3 key stages of developing chemical engineering solutions?
First, we develop the objective, that what thing we are about to work on and what product we require at the end of the process. Second is to work on literature review and get things gathered around what is the work that had been done in the past, what's the findings of that work and or that research, and then develop our research or our approaching way in that direction, so we can make a better findings regarding the previous work that have been done.
That is true. However, I would like you to categorize the stages that are involved in doing all that. Have you heard about piloting?
Pilotic.
Lab scale, and then commercialization.
Okay. So lab scale, I'm also working on a lab scale equipment in our final year project that I'm working on comparison of pyrolytic and co-pyrolytic product blends. And I wish, as we have talked, I wish that I can pursue or continue this project on a commercial level as well. So lab scale is also lab scale is used for research base in institute or small settings, and commercial processes are used for bigger productions.
What happens at the pilot stage?
At pilot stage, I cannot answer this question. I have in mind, but I don't have words to describe.
So you realize there is lab scale. From lab scale, you pilot. From a pilot, then you go to commercialization.
Commercialization.
Yes. So what the findings from a lab scale? From the lab scale, you go to the pilot scale. So I wanted you to tell us what happens at the pilot scale before you can actually go to commercialization.
At lab scales, there were different things that you cannot control, or that could be a parameter that can affect the process at the extreme level. So you convert it to a pilot plant, you set those parameters and control those parameters so it would have that extreme effect on the process, and then you go for commercialization.
Okay, that's good. Now, you talked about process control and analysis. I would like to acknowledge that almost all processes, all industrial processes are controlled. Why? Why should we control these processes? Why don't we just leave them to run without being controlled?
Just leaving them run will result, in my opinion, will always result in casualties, because in USA, there are different USA, India, Bhopal incident, that reaction runaway incident. There were many casualties. So to control the reaction is the I think need of the time, and you cannot just leave things just go around and work their own. So it will cost you not only money but life as well. So you have to control that.
From a chemical engineering perspective, what parameters do we control in industrial processes?
We usually control pressure, temperature, temperature. These two things are main aspect that we control to have the maximum or optimum yield at the end of the process. Flow as well. Sorry.
We talked about pressure.
Okay.
Which instrument do we use for pressure control?
Sorry, please repeat.
Which instrument do we use? Yes, which instrument do we use for monitoring pressure in industrial processes?
Distillation.
Come again?
Distillation.
I'm asking, which instrument do we use for monitoring pressure?
So which instrument we use for measuring pressure?
Yes.
There are gauges, there are differentials, differential pressure instruments. We can use sensors for that as well.
And that's true. That's true. Now, from chemical engineering thermodynamics, it gets revealed that industrial processes can either be open or closed.
Okay.
What's the difference between the two?
Open systems can be processes like that that allow mass and energy to transfer between the system and the surrounding at any instance, and a closed system only allow energy to transfer, not mass. Or you can say you just isolated the system, but you are making an assumption that energy can be out or in of the process.
Okay. There are these two concepts that we use when we are designing equipment, either closed or open: mass transfer and heat transfer.
Okay.
We have just talked about them. You said open system, there is mass transfer and heat transfer, and then closed system only energy, right?
Yes.
Okay. Now, in heat transfer, when you're designing the piping system, what's the most critical element you look at?
The heat transfer coefficient of the material of pipe that we are using.
That's true. Well, as I conclude, you talked about industrial management, and from that, you realize chemical engineers are trained to be good leaders and managers of industrial projects.
Okay.
Right?
Yes.
What are the key 5 managerial functions that a chemical engineer should adopt or should learn to be effective at work?
Process safety, the details or the details of the process that we are working on, and the product that you are getting, you have to optimize it, and I think these things will be fine.
Khalid, I'm asking, as a chemical engineer, there are two situations. You have the technical skills and you
Okay.
have managerial competence.
Okay.
From the management perspective, what are the key functions or key critical skills that you should adopt or should learn to be effective as a manager of an industrial project?
Good communication, good costing
Yes.
skills. You should be aware of what additions you could make to the process, or what reductions you could make to make the maximum profit out of it.
Oh, that's great. Well, thank you for being confident and for having the required skills.
Thank you for taking your time to meet me.
Please, over to you, Hassan.
Just a couple of quick questions, Shazar, if I can ask Umair. Umair, Shazar, how are you?
I'm fine, thank you. What about you?
Okay. Yeah, I'm well. Thank you. Just a couple of questions. I'll keep it brief and quick. Tell me about what's the difference between a manipulated variable and what's the difference between a manipulated variable and a response variable? Because you told me that you have studied instrumentation and process control, right? Bernard was asking you some questions about it, so it's better that we can touch that aspect as well, no?
Okay.
These are pretty general terms, you know that, right?
Yes.
Okay, so go ahead.
Manipulated variables are variables that can be manipulated to control the system or control the process. And the second thing, the second one you asked was responsive. What was this?
Response.
Response. So response is the kind of indicator of the process, that how the process respond to particular change in particular parameter, or you can say
okay,
two or different
so
parameters.
Okay, so give me one example of each variable, quick.
Manipulated variable could be temperature, and response. Response is due to temperature, that change temperature brings to the process.
Give an example of that, right?
Damp process, or
no.
I can think of an example of response.
That is not a variable. That is actually what I was studying. That is actually the control behavior of the control system.
Okay. System.
So yeah, so I'm asking about, you just gave me one example. If it's assume that we have a control system of it. We have, for example, a reactor. Okay, we have a reactor. We have like some liquid in it. Okay, so we have a control loop of it. The temperature is very important for the product which is being developed. Okay, so and there are like temperature and pressure indicators on the reactor. Okay, so what happens at when the V shape is get charged into the reactor, an exothermic reaction proceeds and undergoes, for example. So in this scenario, what would be and for this reactor, since it's an exothermic condition, so I'm actually cooling the reactor with the jackets, and for example, assume it's a simple case. So we are cooling the reactor with the jacket. I'm supplying cooling water across the jacket. So in your view, what are the control? What would be my manipulated variables? And as I've told you that I've charged VCM into the reactor and VCM gets converted into the PVC. So for example, what would in this case be my manipulated variable and my response resultant variables that I can expect?
Response variable, and the second was manipulated variable. So manipulated variable could be the amount of cooling that is required, regarding that you are giving giving the cooling medium in the
Right.
jacket, because you talked about exothermic reaction, so that
Yeah.
needs cooling reaction.
Right.
So and the second one is response variable. Response variable is the uh, I still don't get it. I cannot
Like
explain it.
for example, it's just a suspension of PVC in water. So
Hmm.
what would be the parameter that might get impacted by it, for example? It's just a slurry, for example. Take that as a case.
And what could be example? The
Can
reaction
con
time.
can concentration be my variable?
Yes, concentration can be a variable, because concentration, if you're talking about sedimentation, uh, जितनी आपके पास रिएक्शन होता जाएगा उस हिसाब से आपके पास कंसंट्रेशन भी चेंज होगी और सेडिमेंटेशन के लेवल्स भी आपके
Okay.
पास चेंज हो सकते हैं.
ठीक है, get your point. ठीक है, okay. So tell me, like briefly respond to me what are the different types of reactors that are available in industries? Just an example of it, like quick.
Continuous stirred tank reactors, plug flow
Right.
reactors, batch reactors.
Okay. And what's the basic difference? What's a batch reactor?
Batch reactor is the things on that it don't have an inflow. It's a batch reactor. You only feed the reactor once a time, and then you can exit the collect the product out of the outlet. Continuous stirred tank reactors are continuous reactors or mixed flow reactors, in which feed can be the reactor can be feed at any time, and the product can also be collected at any time. Plug flow reactors are also a type of mixed flow reactor, but it's a long cylindrical pipe reactors, which gives more efficiency than the continuous stirred tank reactors.
What's the difference between the different controllers that are available? For example, um, the parameters that are associated with the controls. Like for example, there's a control valve, a temperature control valve. What's the significance of the proportional, integral, and derivative part of the algorithm? And the second, yeah, go ahead.
Proportional is for I cannot answer this question. Sorry.
Oh, okay.
I'm not.
And if I ask you, it says that there is a control valve that is an equal percentage control valve. So the characteristic of the equal percentage control valve is equal to that of the proportional controller. Would the response behavior, control behavior of both the valves would be the same? Are these two things same?
No.
No. Okay.
There will be a difference.
And what's the difference between a modified equal percentage valve and an equal percentage valve? Is there any difference between it?
No. इनके अंदर नहीं होगा.
So there isn't any difference between the modified equal percentage valve and an equal percentage. Okay. And what's the basic definition of an equal percentage valve?
What you have said? What's the difference between?
What's the basic definition of an equal percentage valve?
Equal
What's the
percentage.
basic definition of it? Yeah.
Equal percentage valve. No, I cannot answer.
No idea. Have you heard of the term CV?
In terms of what? CV.
CV. Have you heard the term flow coefficients?
No.
Flow coefficient CV. What is the
flow coefficient? Yes, I've heard about flow coefficients.
So where it is used? What is the basic significance of it?
It is used in the valve and used in the valve because of the friction that is caused due to the friction.
All right. And one last question before we conclude: Can I have a valve designed without having my CV specified? Can I have a valve specified before specifying a CV, or is it mandatory for me to specify a CV first and then go for the valve designing?
First, you have to specify the CV, then you go for valve design.
And how is the CV proportional to the flow rate?
flow rate, it increases.
Sorry,
It increases.
it increases in what portion?
In it increases with the increase in flow. Sorry.
That's the exactly thing that you says in the first place, buddy. You just rephrased your comment. Anyways, thank you and keep your learning antennas on. And you have a very good communication skills. And it's just that based on the conversation that I had during the entire course of this session, I think that one area that you can improve and you have the capability to improve is giving people a bit of a courtesy. I might be sound weird or something like that, but with the panel of people here, it's a bit of, it feels a bit awkward at times when if you haven't heard any, if you are having trouble listening to other person, just ask him that I haven't got your question right, instead of expression, giving your
Okay.
expression, anything like that. So that is an area that you can improve on, because that's an attribute people look out for. So that is like one thing, but other than that, you have a very good communication skills. Technical aspect person like develops with time.
Okay, I'm really sorry. This is my first interview experience. That's why I was just nervous. So it just happened.
Keep it up, buddy. Keep it up. Keep it up. Keep it up, buddy.
Thank you. Thank you. Thank you for taking your time to meet me.
And
Thank
no
you.
issues. As you go through multiple interviews, you will learn with time that how to handle the pressures and how to communicate, uh, on what reply you will need to share with the interviewer, so that interviewer will not ask you multiple questions on the same topic. So I've given you a separate feedback on the WhatsApp, and thank you very much.
Thank you. Thank you, sir. Can I leave?
Yes, sure. Shazir, this time you will start with the introductions.